Hello, hello. I'm Mr. Monty, and we're here on Tuesday, day 15 of Unit 5, February 25th. So today we're going to put it all together as we start to wind down on this unit. We've done a lot of work on given any polynomial, we can find the zeros, we can find the intercepts, we can find all the factors. Now let's go back and see if we can remember our end behavior and look at some specific ideas and what we need to review to make sure we have all the skills to be successful on our final. Today you're going to get a packet of a bunch of review type problems. The first couple, actually the first 6, all deal with end behavior. So with end behavior, we're going to get problems like f of x is equal to 3x to the third plus 5. If we were given this function, what would we see? Try to picture it. Well, the first thing we should look at is the x to the third. Okay? We look at this piece right here. And we know that if it's an odd function, it's got to be something that starts low, finishes high, starts high, finishes low. Okay? So we're going to draw a grid like this, and we know, because it's an odd function, it's either going to go like this, and like that, or like that, and like that. Okay? Okay? So we have the odd function. This 3. When the 3 is in front of the variable, stretch. So we have a vertical stretch by 3. And then this 5, when it's on the outside, away from the actual variable, that's after the fact, and that's a shift up or down. So we have a vertical shift. And in this case, up 5. Now, end behavior. End behavior. Negative infinity cubed gives us negative infinity. Positive infinity cubed gives us a positive infinity. So if the question was, give us a sketch of 3x to the third power plus 5, it would be starting low, finishing high. So we'll erase this, and this would be some sort of a shape that we would see, something like this. Okay? So use those skills in breaking it down to answer it. Let's look at another one of those. That's an even function. Now if we had an even function, and we'll do something a little more complicated. Negative 3x to the fourth plus 2x squared plus x minus 5. Well, the last week we know that we could go through, divide all this out using the rational root theorem, all the negative 5's divided by all the negative 3's, and find out the actual zeros. But that's not what we're looking for. We just want to focus on end behavior and what we think the rough sketch would look like. So let's draw a graph. And the very first thing I always look at is the exponent, the degree of the function. That's the one with the biggest exponent. So it's a 4th degree polynomial. That's an even function. So when it's even, that means it either finishes both up or both down. It has to be either both up or both down. Okay? This negative, we flip the x-axis. So now we know it's going to be both down. Down, down. So far, so good. This 3 vertical stretch by 3. And then the last thing, this would be a horizontal, good catch, not horizontal, vertical shift down 5. Vertical shift down 5. Okay? So we have some sort of parabolic shape. It's been shifted down 5, and the end behavior, both of them aiming down. Okay? So remember those skills when you do like the first 6 on this worksheet. Okay, then the next thing we're going to do, there's going to be 2 or 3 problems where we want to evaluate. Okay? The last couple of days we talked about when we're given an actual value for the x. Actually, let's just look at our original equation. If I gave you a function, f of x, and we said 3x, x minus 3, x plus 4. Okay? Just an arbitrary function. Let's analyze this, get a rough graph, and then evaluate at the point 1.25. Let's see what we'd have here. Okay? First thing we look at, since it's in factored form, we have the zeros. One of the zeros is going to be 0, 3, negative 4. So those are our zeros. Let's get a rough graph of this. So we have something happening at 0, something happening at 3, and at negative 4. 1, 2, 3, 4 in the negative direction. Okay? Now, what's our degree? Let's recap a little bit here. The degree of this function, if we were to expand it out, this times all this times all this, x times x times x, x to the third. So it's a third degree polynomial. Okay? Third degree polynomial has to be odd. That's an odd function, and it's positive. Remember the end behavior? It's either low to high or high to low. Good. Coming up, finishing up. So we have some sort of a rough like that. What's our leading coefficient? The leading coefficient, if we multiplied all this out, 3, we have the x, a 1x, and a 1x, so 3 times 1 times 1. So we have a vertical stretch of a factor of 3. Good. So we have the degree, the leading coefficient. I think we could get a rough idea here. Odd function, odd function, odd function. That means it crosses, crosses, crosses. Good. All right? Cool. Now, let's take it one step further here and talk about if we took this function, what would happen if the actual point 1.25? Well, if we had a calculator and we graphed it, we could actually go over to 1.25 and evaluate that point. Okay? So we would go to 1.25, and wherever the curve hit it, that would be our answer. Or we could actually put this value into our function. So we're going to go f of 1.25 is equal to 3 times 1.25, 1.25 minus 3, and 1.25 plus 4. We could use a calculator and actually come up with all these values. Okay? So 3.75 and 1.75 and 5.25 and multiply all that out? We could, absolutely. And then come up with our final value. This would be a negative, wouldn't it? Yep. That's how we're going to come down here. Okay? So make sure you use these skills on the middle part of this practice packet. Okay? And then at the end of this packet, we got to return and focus on that vertex form. We're going to spend a couple of days on vertex form before this unit's over. And let's look at an example here. Vertex form. You guys remember what that might look like? The general form of vertex form is a x minus h squared plus k, where h comma k is the vertex. Okay? So if we're given this form, then we can analyze it and say where the vertex is. H comma k. When it's with the x, it's the opposite, so it's positive h. When it's on the outside, it's just the positive. Okay? Now, let's look at an example. If we were given this example, there's several things that we can analyze first and then go and put it in standard form. Okay? So let's just start out by marking it up. Very first thing, the 3. The 3 is on the outside, okay? On the outside of the function, of the variable. Remember what that does? This a value is a vertical stretch, okay? It either makes it grow faster or not so fast. So we have a vertical stretch by 3. Okay? This inside piece. Remember what the inside shift is? Remember our transformations from early in the year. When it's on the inside, it's the opposite. And this one is a horizontal shift, -1. Good. And then when it's on the outside away from everything, that's our vertical shift. In this case, it'd be down 4. Down 4. And it's to the second power, so it's an even function. Okay? Even function. And it's in the positive direction, so it's going to be some sort of parabola-looking shape. Let's sketch it real quick. Okay, so the first thing we need to do is go over -1 and down 4. 1, 2, 3, 4. We're going to have our vertex. Okay? We know that our end behavior, parabolic, positive. So we're going to have something up here and something up here. But let's be specific on this. We're not going to sketch this one. We can actually do the whole thing here. Let's put this in standard form so we can find the vertical intercept. Sure, the y-intercept, we could find that. And plug some points in. Okay? So, let's take this and expand it. 3x plus 1, x plus 1, minus the 4. First thing we want to do, multiply all this together. We could do FOIL it. That times that, that times that, that times that, and that times that. Or use the area model. X plus 1, x plus 1, x squared, 1x, 1x, and 1. Putting it all together, we're going to have that 3x squared plus 2x plus 1. Bring it down, minus 4. Distribute the 3. 3x squared plus 6x plus 3 minus 4. Finally, 3x squared plus 6x minus 1. Okay? Now maybe you already saw that here. We could have gone 3 times the 1 minus the 4, giving us a dot at -1. Okay? And now we can see our shape starting to form. Okay? And if we wanted, we know how to take this and actually find the zeros. Remember how to find the zeros of any quadratic? Use the quadratic formula? Absolutely. Let's see if we could fit that in right in this little space here. You remember the quadratic formula? Let's write that off to the side here. The quadratic formula, the opposite of b plus or minus b squared minus 4ac all over 2a. We have our a value, our b value, and our c value. Okay? Let's plug it in. So we have the opposite of b, minus 6, plus or minus the square root of 6 squared minus 4 times 3 times a negative 1, all divided by 2 times the a value of 3. So negative 6 plus or minus 36 plus 12 all over 6. Got some ugly numbers here, don't we? Negative 6 plus or minus the square root of 48 all over 6. What's the square root of 48? Well, the square root of 49 is 7, so it's just a little less than 7. Good. So we're going to approximate. Approximate sign, negative 6 plus or minus nearly 7. So let's just write 6.9 for right now. All over 6. That gives us two values. Negative 6 plus 7 over 6. So that's going to be 1 over 6. So it's going to be really close to the value of 0. And then negative 6 minus 7 over 6, negative 13, negative 13 over 6, so a little past 2. So we have negative 13 over 6 and 1 over 6. Okay? Remember what those are called? Our factors. So given the vertex form and all the skills we have of end behavior, factoring, there's a lot we can do now. So use these skills that we just talked about in this video and work on this packet and bring your questions to class tomorrow. See you then.